Have you ever stopped and wondered how your phone knows exactly, and I mean exactly, where you are? It all comes down to this amazing invisible grid that's wrapped around our entire planet. So today, let's pull back the curtain on that grid and really get into the simple but kind of brilliant system of latitudes and longitudes.
So let's kick things off with a little thought experiment. On land, giving an address is pretty easy, right? You've got streets, houses, landmarks. But what if I asked for the address of one tiny spot, right in the middle of the Pacific Ocean? That's the real challenge here. How do you describe one single point on a giant, mostly empty sphere?
I mean, just think about it. A perfect ball doesn't have a natural top or bottom, or a built-in starting line. There's nothing to grab onto. So to solve this, we can't really use what's already there. We have to, create our own reference points. We literally have to draw our own lines around the globe.
So where do you start? Well, the most obvious place is right smack in the middle. Let's just imagine drawing one big line all the way around the Earth's widest point, perfectly halfway between the North Pole and the South Pole.
And this line, this super important reference line, is called the equator. Now this is a big one, a term you've absolutely got to know. It's totally imaginary, of course, but it's the single most critical starting point for this whole global address system.
So the equator, it slices the Earth perfectly into two equal halves. We call them hemispheres. Everything north of that line, that's the northern hemisphere. And everything south of it, you guessed it, the southern hemisphere. Nice and simple. It's the perfect first step.
Okay, so we're making progress. Knowing if you're in the north or the south is great, but it's not quite enough, is it? We need to know how far north or how far south a place is from the equator. And to do that, we're going to need a few more lines.
And this brings us to our next key term, parallels of latitude. The easiest way to think about them is like stacking a bunch of rings on a ball. They're a whole series of imaginary circles, all running parallel to the equator, and we measure the distance using degrees.
So our starting point, the equator, that's our 0 point, 0 degrees latitude. And as you move away from it, going north or south, the degrees start to go up. And you'll notice something else. The circles themselves, they get smaller and smaller the closer you get to the poles.
So how high do the numbers go? Well, from that 0-degree equator, the count goes all the way up to 90 degrees north, right at the tip top of the North Pole, and all the way down to 90 degrees south, at the very bottom, the South Pole.
Now, besides the equator and the poles, there are 4 other famous parallels that are really worth remembering, especially if you've got exams coming up. In the northern hemisphere, you've got the Tropic of Cancer and the Arctic Circle. And then down in the southern hemisphere, you've got the Tropic of Capricorn and the Antarctic Circle.
Okay, so our north-south position is locked in. We've got that figured out. But this only solves half the problem, and let me show you exactly why.
Check this out. Take the Tonga Islands out in the Pacific Ocean and the Mauritius Islands in the Indian Ocean. Both of them are located on the exact same latitude, 20 degrees south. But they are thousands and thousands of miles apart.
See what I mean? It shows we're still missing a huge piece of the puzzle. We know how far up or down we are on the globe, but we have no way of telling how far east or west we are. We need a second set of lines.
And the answer is our next big term, meridians of longitude. Now, unlike those flat, horizontal circles of latitude, these lines are vertical. They're actually semicircles that run straight from the North Pole all the way down to the South Pole.
But wait a second. This gives us a totally different kind of problem. With latitudes, the equator was the biggest circle, so it was the natural starting point. But with longitudes, every single one of these meridians is the exact same length. There's no natural middle one, so one had to be chosen. So basically, all the countries had to get together and just pick one. By international agreement, they decided that the starting line, the 0-degree longitude, would be the meridian that passes right through the British Royal Observatory in Greenwich, England. And that line became known as the prime meridian. All right, we have our 2 different sets of lines. We have our latitudes and our longitudes. Now it's time for the fun part, putting them together to build our complete global grid.
So on the one hand, you've got your horizontal parallels of latitude telling you how far north or south you are, and on the other hand, you've got your vertical meridians of longitude telling you how far east or west you are.
And when you lay them over each other on the globe, boom, they create a complete network. This is our grid. It's almost like we've taken the whole planet and wrapped it in a giant sheet of graph paper.
And that's really the magic of the whole system. It's just like that game Battleship, right? Any single location on the entire planet can be found by that one unique point, where a line of latitude crosses a line of longitude. That intersection gives it a one-of-a-kind address on our global grid.
So for example, if you wanted to find the town of Dhubri in Assam, India, all you need are its two coordinates. You find the line for 26 degrees north latitude, and then you find the line for 90 degrees east longitude. And that one exact point where they cross, that's Dhubri, nowhere else on Earth.
Now, I know what you might be thinking. This all just sounds like some abstract thing for geographers and old dusty maps. But the truth is, this completely imaginary system has a huge, direct impact on your life every single day.
Here's why this really matters. You know that GPS, the global positioning system that your phone uses to give you turn-by-turn directions? Well, it is powered by this exact same grid of latitude and longitude. It's this system that lets your phone know your precise location on the planet at any moment. It's amazing.
It's just an incredible example of how a completely imaginary idea, a simple grid of lines, totally changed how we navigate and understand our physical world. And that kind of leaves us with a final thought to chew on. This grid organized our physical space. What new, invisible system are we building right now that's going to organize our digital world?